Okay, so the way I did this complicated L'Hopital's problem yesterday is just one way to do it, and I think there's another way that for some of you might feel easier. So I'm going to show you this other way. So what we're going to do, kind of like what I started with yesterday, is let's just let that equal y. And if we just let that equal y, we're going to say that y equals 3x to the x. And so really, what I'm looking for is the limit as x approaches 0 from the right of y. We'll come back to that later because that's what we're really going to answer. But for now, let's just play with this. So if I'm looking for the limit, let's go ahead and just take the limit of both sides. And we can tell that this would definitely be a indeterminate. You'd end up with 0 to the 0 power. The 3 there is kind of insignificant. It doesn't really play a big difference. It'll change our answer, but not really significant how we're going to attack this problem. So what I did yesterday is I changed this base to e to ln of the base so that we could kind of get it in terms of e. There's another way to do it. You could take the natural log of both sides. So if I take the natural log of both sides, I'd be asking for the limit as x approaches 0 of the natural log of y, and we'd say that equals the limit as x approaches 0 of the natural log of 3. I'm just going to go ahead and use all my rules here, right? So they're multiplying here, so I can add that as logs. That's an exponent, so I can move the exponent out in front. And so now I have this statement. Now I can't quite use L'Hopital's yet, and actually I'm going to use parentheses around that. I can't quite use L'Hopital's yet. This is just a number, so that's pretty simple to evaluate. It's just ln3. But what I can do is I can change this to a fraction. I could change it to a fraction by doing this. So we got the limit as x approaches 0 of y equals the limit as x approaches 0 of ln3, which, like I said, is actually just ln3. We can write that in a second, plus the limit as x approaches 0 of I want to put ln x up here, and I can just move x to the bottom by making it x to negative 1. And now, in this situation, these ones I don't really need to focus on, but in this situation, I do have a L'Hopital's here, because if I was actually plug in a 0, I'd end up with the natural log of 0, which is really negative infinity, over 0 to the negative 1, which is really like that. So, which is really like infinity. So that's an indeterminate form. Okay, so we can use L'Hopital's. So the limit is x. I'm just copying this down each time equals. That's just the natural log of 3. We know that. But now I can go ahead and actually take the derivative of the top and the bottom using L'Hopital's rule, which would give me 1 over x over negative x to the negative 2. And we could kind of, if I was to just kind of play with just that, just simplify just that, what is that? That's really like saying 1 over x over negative 1 over x squared, which is like saying 1 over x times negative x squared over 1, which lets me cancel out some of those x's. And so really it's just like saying negative x. So if I go back, I have the limit. Oops. Some of you guys might have noticed I made a mistake here. There should be an ln(y) here, ln(y). That's really important. We'll find out why later. Okay, so L'Hopital says instead of taking the limit of this, I could take the limit of what I got here, which ends up just being, remember, this just ends up being negative x. So really I'm just taking the limit of negative x. Well, that's pretty easy to do now, because what we can find is that if I actually plug in a 0 there, we just get negative 0. So this whole thing equals the natural log of 3 minus 0, which of course is just the natural log of 3. Okay, all that. But let's go back to what I have here. Remember, this is the limit as x approaches 0 of the natural log of y. So I'm going to try and give myself some space here. And so now this is the part that's a little bit different. I'll do it in blue. So So the limit as x approaches 0 of the natural log of y equals the natural log of 3. Remember, I don't want the limit as x approaches 0 of the natural log of y. I want it of just y. So let's go ahead and raise both sides to e. And we would have the limit as x approaches 0 of y equals, well, e to the ln of 3 is just 3. And so we found our answer is just 3. So there's another way to do it. I thought it was important for you to at least see that other way. Yeah, have fun with these problems. They're a blast.